Yo, 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 geometry, what is up? This is Mr. Terran rocking with you today. And today we're going to be looking at translations. This is the second out of four videos covering transformations on the coordinate plane in geometry, chapter 12. So, without wasting any more time, let's get after it. Here we go. So, translations, other common words you'll hear for translations are probably something like sliding. So a slide or sometimes a shift. You'll hear a lot of shifting, especially Algebra 2, FST, Pre-Calc 2. So let's just, before we get into translations, remember this is the second type of transformation on the coordinate plane. Once we look at some examples of translations, and we'll start talking about translation rules and how to use them on the coordinate plane. But let's look at is a translation? Is it sliding at all? Well, no. It looks like this looks like a reflection from last time, right? So that's actually not a translation. But if you look at B is a translation. It looks like the blue shape has transformed or translated or slided or shifted into the red shape. And just keep in mind with all our transformations, except for dilation, for translations, rotations, and reflections, the shapes should maintain the same exact shape and size. For C here, that looks like, again, it looks like it's maybe a rotation or a reflection, but certainly not a translation. But D looks like another translation, right? Because we're just sliding it along. All right, so we're going to skip that slide for now. So the two, translations can be written in two different ways. All right, so if I were just to say, hey, let's translate something, I don't know, up 3. Sorry, let's not go up 3. Let's go to the right 3 and down 6. So say I want you to translate that. I want you to take a shape and move it like that. Well, there's a couple times we can write it. The first way is if I were to do this exact translation, is it'll say something along the lines of it'll say translate on the vector, and vector is just a fancy word for like basically a straight line or a direction with yeah, on the vector, and then it'll give you this like pointy bracket. And for this one, since it's going to the right 3, remember it's always x comma y, so it'd be translate on the vector 3, negative 6. And what that's saying is we're going to the right 3, so positive 3, and we're going down 6, so minus 6. Okay, the other way that we talk about translations is we'll say x comma y has shifted or translated to x plus 3, y minus 6. Because if you think again, if you think about going to the right, that's adding 3 to your x value. And if we're going down 6, that's subtracting 6 from the y value. So please know how to do both of these, because both are on the test, both are in your homework, both are on the study guide, and you need to know both. All right? So I'm either going to give it to you like this, where I'm just saying, hey, these are the rules, or I'm just going to say, okay, well, it's x plus 3 and y minus 6, and instead of just saying plus 3 minus 6. All right? These questions are very good questions, and you'll see them everywhere, so you might as well get used to them. But hey, what is my translation? Write it in both forms. Well, if I look here from 3 to 6, what happened? Well, I mean, simple math tells us we added 3. So one way I could write that would be 3. And then what happened from 9 to 2? Well, we subtracted 7. Sorry, we said that's plus 3. We subtracted 7, so you could write minus 7. And that's just saying, hey, we're moving our coordinates to the right 3 and down 7. That's it. The other way you would want to write it would be something like this. Oh, okay. Well, x, y is transforming to x plus 3, y minus 7. All right? X plus 3, y minus 7. And so now using either one of these rules, let's see, well, what would happen to negative 1 comma 0? Where would that end up applying that? Well, if I were to add 3 here, that would be positive 2. And if I were to subtract 7 here, that'd be negative 7. So that's where your new coordinate would be. All right. I want y'all to try and do this one. So go ahead and pause the video and try this one on your own. If you're having a hard time, though, you can always not pause it because I'm going to go over right now anyway. But go ahead and pause it if you'd like to try it. If not, we're going to go over right now. So, again, from negative 1 to negative 6, looks like I'm subtracting 5 from negative 1 to negative 6. So I'm going to go minus 5. And from positive 4 to positive 14, looks like I'm going up 10. So that's what it would look like that way. Or you could just say something like x minus 5, y plus 10. Both of these would be correct. And so where would negative 1 comma positive 1 end up? Well, looks like we're just going to subtract 5 here, so that's going to be negative 6. It looks like we're going to add 10 here, so that's going to be positive 11. And that's really all you have to do for these. All right. Okay. Some of you might know what I'm referencing. And I think I'll, again, pause the video if you want to do this last one. We're asking what is the translation from a to a prime. But we're going to solve it right now if you don't want to pause. So from 20 to 6, looks like we're subtracting 14. And from negative 4 to negative 4, looks like we're not doing anything. Right? I'm not doing any change. So I'm going to put a 0 there. So in my two forms, it looks like it's going to be negative 14 comma 0. Because we're not changing the y at all. Or you can just go x minus 14 comma y plus 0, or you could go x minus 14 comma y. I would take any of these answers. All right. Now these next few slides is going to kind of sum up what we've already talked about, so I should be able to go through these pretty quickly. If we have a horizontal translation, notice all that's happening is my x is changing from x to x plus a, whatever that is. So x, so from p to p prime is just x plus a comma y. And a could be a positive or a negative number depending on if you're sliding right or left. So translate these points. So this is exactly what I was talking about right here. Translate this point using this vector. So again, looking at this one as well, these are different types of notation. You need to know both. So 4 comma 2 using this notation just means we're going to move, looks like the x value to the left by 1 unit by subtracting 1. So it's going to be 3 comma, and it looks like we're not changing the y at all, so the negative 2 will be the same. And the 3 is going to the left one, or subtracting 1. Looking at this other type, we have negative 3 comma 5. We're going to add 2 to that, so that's going to be negative 1. And we're not going to add anything to that one, so we're just going to go 5 right there. And that would be my new coordinates. A vertical transformation is very similar, except now we're going from y to y plus b. Again, b could be positive or negative. So we're going to translate these points. 4, negative 2. on the vector 0, 2. Our 4 will stay the same. And negative 2 plus 2 will be 0. Negative 2 plus 2 is 0. And looking at this one right here, it looks like, again, our x value is not changing, and our y value is going from 5 minus 4 would be positive 1. And then lastly, general translations, that's kind of what we've done, in the beginning. I guess the notation for this x plus a, y plus b, remember, it could be positive or negative. So if here's my coordinate, my original coordinate, and here is my translation rule, it looks like I'm just adding 1 to the x, so that's going to be a 5, and I'm subtracting 2 from the y, so negative 2 minus 2 is negative 4. And over here, looks like I'm adding 3 to the x, so negative 3 plus 3 is 0, and 5 plus 7 is going to be 12. So overall, not too bad, just adding and subtracting numbers. Last thing that's going to be asked of you is drawing translations. Again, you're just going to plot and label your original points, apply your translation rule either in the vector or that mapping notation, and then plot and label your new points. Same thing as reflection. So right here, it's giving you the vector. Let's go ahead and plot our different points. Let's plot them in, let's go red. So R is at 2, 5, 1, 2, up 1, 2, 3, 4, 5. So here's R. S is at 0, 2. T is at 1, negative 1, and U is at 3, positive 1. S, R, so we have R, S, T, U. Okay. Now we're going to apply this vector, and it looks like we're subtracting 3 from both. So 2 minus 3 would be negative 1. 5 minus 3 would be positive 2. 0 minus 3 would be negative 3. 2 minus 3 would be negative 1. 1 minus 3 is negative 2. Negative 1 minus 3 is negative 4. 3 minus 3 is 0. 1 minus 3 is negative 2. So now that I have those, I'm going to plot those. So R prime will be at negative 1, 2. So negative 1, 2 is, here's R prime. S prime at negative 3, negative 1. So right here. T prime at negative 2, negative 4. So right here. And U prime at 0, negative 2. Right here. And if we did this correctly, the shape should stay the exact same. Just everything should slide down by the same amount. And that looks pretty good. So that's translations. Just literally sliding things around, adding or subtracting to our x and y values. If you have any questions on translations, make sure you reach out to your teacher. Email is probably the best way. But that's all we got for this video. Hopefully it was helpful. Y'all have a nice evening, afternoon, morning, whatever you're having. Taryn out.